All right, welcome back for example 3. We're going to be looking at some similar triangle application problems. So let's get started. It says a picture is 10 inches tall and 14 inches wide. Is to be scaled to 1.5 inches tall to be displayed on a web page. How wide should the picture be on the web page for the two pictures to be similar? That is the same shape, but not necessarily the same size. I'm going to go ahead and just draw a picture here. So 10 inches tall, 14 inches wide. So I guess it's going to be wider than it is tall, right? Okay, so something like that. 10 inches tall. Oh, well, anyways. This picture is not drawn to scale. 14 inches wide. So 10 inches tall, 14 inches wide, and it's to be scaled to something that is 1.5 inches tall. And we don't know how wide. That's what we're trying to figure out. So we know that this and this, those are similar. So our proportion is going to be 10 over 1.5. Those are corresponding sides, the tall sides, right? And that's going to equal the wide. So 14 over x, right? We're trying to figure out how big this needs to be. So I think this is a great problem to use that cross products property. Okay, so we have 10 times x, which is 10x, equals 14 times 1.5. I'm not sure what that is. I'm going to take that over here and figure out what it is really quickly. 5 times 4 is 20. Write the 0, carry the 2. 5 times 1 is 5, plus 2 is 7. Put a 0. 1 times 4 is 4. 1 times 1 is 1. 0, 11, 2, and just a 1 decimal place. So 21. All right, perfect. And then we're trying to determine what x is, right? So this is multiplication. I'm going to do the inverse operation, divide both sides by 10. And we're left with x equals, when we divide by 10, it moves over 1 decimal place, so we get 2.1. So how wide should the picture be on the web page for the two pictures to be similar? Let's say the picture should be 2.1 inches wide on the web page. Okay, and that is our answer. Perfect. Okay. Let's go ahead and look at this next example. If I can move up this piece of paper. All right. It says, B, a t-shirt design includes an isosceles triangle with side lengths 4.5 inches, 4.5 inches, and 6 inches. An advertisement shows an enlarged version of the triangle with two sides that are 3 feet long. What is the length of the third side of the triangle in the advertisement? So I'm going to go ahead and draw a picture. Right, an isosceles triangle, which means that there's two sides that have the same length. So that's going to be our 4.5, and this is going to be our 4.5, and then this is going to be our 6. So it says an advertisement shows an enlarged version of the same picture where the two sides are 3 feet long, right? So these were inches. And 6 inches, and now it's 3 feet on both of those sides, which are the same. What is the length of this third side here? Okay, so we know that these two sides are corresponding sides, right? So I'm going to set up my proportion and go 4.5 over 3 equals, and then these two are also corresponding sides. So I'm going to have it be 6 over x. And then this one just looks like a great one for the cross products property. So I'm going to go 4.5 times x, which is 4.5x, equals 6 times 3, which is 18. Okay, then we just need to get x by itself. So we're going to divide both sides by 4.5. That becomes 1. X equals, and I'm just going to take this on my side over here. So 18 over 4.5, right? We can't divide by decimal, so we have to Move the decimal place over 1 and move it over 1 here. 45 doesn't go into 18, but it does go into 180. How many times? Let's think about this. I'm going to say, I think it goes in, so 2, maybe 4. I think it goes in 4 times. Let's see. 4. 4 times 5 is 20. Write the 0, carry the 2. 4 times 4 is 16, plus 2 is 18. Exactly 4. So x is 4, which would mean, what is the length of the third side of the triangle in the advertisement? That would be 4 feet. The third side, oh man, is 4 feet. All right, in the advertisement. Perfect. Okay, now it is your turn, ladies and gentlemen. I want you to try C and D on your own. Okay, make sure you set them up as proportions and then solve accordingly. Here's my friend the pause dragon. Remind you to pause your device. Go ahead and work out those 2 problems. When you get done, press play and we'll talk about them. All right, see you in a bit. Okay, let's see how you did. It says a photo is 12 inches wide by 18 inches tall. So I'm just going to draw a picture of that really quickly. So 12 inches wide by 18 inches tall. If the width is scaled down to 9 inches, okay, so it's going to be smaller. So it's saying this is the width, right? So this is 9 inches. How tall would it be? All right. So what we know is we know that the width, these are corresponding sides, okay? So I'm going to go 12 over 9. And then I also know how the tallness, those are corresponding as well. And that is going to equal 18 over x. So from here, I'm going to use that cross products property. So 12 times x is 12x. Equals 18 times 9. I'm not sure what that is. 72. 9 times 1 is 9 plus 7 is 16. 162. That looks right. And then we are going to get x by itself, so divide both sides by 12. 12 divided by 12 is 1. We're left with x. Let's see here. Okay, so 12 goes into 162. How many times? I'm not sure. 12 does not go into 1, but it goes into 16 one time. 4, 2, it doesn't go in evenly there. So I think I'm going to reduce this fraction. Oh, what do I know goes into it? I know 3 goes in, so this is 4. And 3 goes in here because 1 plus 6 is 7 plus 2 is 9. So 9 is divisible by 3, so I know 3 goes in there. Let's see here, 162 divided by 3. 3 goes in there 5 times. 5 times 3 is 15. And then 3 goes into 12 4 times, so we're left with 54. Okay, and I can see that 2 goes into both of these. 2 goes into 4 2 times, and 2 goes into 54. I'm not sure. 2 goes into 5 2 times. 2 times 2 is 4. 1, 7. Okay, so 27 times. So there we have 27 over 2, which would be, I think, 13.5, right? Since we're talking about length. Or we can talk about 13.5 inches. Because 27 over 2, 2 goes in there 13 times. With 1 left over, so 13.5 inches. So how tall will the similar photo be? It will be 13.5 inches tall. So if you got that right, great job. Good work, good work. Okay, let's go ahead and look at D. Now D is talking about an isosceles triangle again. It says an isosceles triangle has a base of 20 centimeters and legs measuring 36 centimeters. So we have this is our isosceles. The base is 20, the legs are 36. It says, how long are the legs of a similar triangle with base measuring 50 centimeters? So this one is definitely bigger. And it says that the base is 50. So we're trying to figure out what is this side length. Okay, what do we know? We know the bases are similar, right? So we can go 20 over 50. And then we know that these two sides are similar here, 36. I mean, they're corresponding sides. That's what I meant to say. So this is equal to 36 over x. We're just going to use that cross products property. So 20 times x would be 20x equals 36 times 50. I'm not exactly sure. That would be 0. 5 times 6 is 30. 5 times 3 is 18 plus 3 would be, no, 5 times 3 is 15 plus 3 is 18. Okay, let me just double check that. 0, 30, 15 plus 3 is 18. Okay, so 1800. We want to get x by itself, so we're going to divide both sides by 20 using the inverse operation of multiplication. That is 1. We're left with x. I love these. The zeros cancel out. And 2 goes into 180 90 times. So how long are the legs? The legs are 90 centimeters. Okay, and if you got that one right, yokodenki mashita, you did a wonderful job, and I will see you next time.